With the PASCO wireless smart gate, you can measure the period of a pendulum, the speed of a projectile, and much more. The wireless smart gate measures the timing of events, such as an object passing through it. It features 2 photogate beams, a laser switch, and an accessory port. It includes a mounting rod and a USB cable. We will look at 2 applications, the first using SPARKvue software, and the next using PASCO Capstone software. First, let's use the smart gate with SPARKvue to study a pendulum. I've already started SPARKvue and connected the smart gate through Bluetooth. To tell SPARKvue how I'd like to use the smart gate, I click the Configure Sensor button and select Smart Gate Only, then select Photogate and Pendulum. Our pendulum here happens to be this width, but we could change it if needed. Next, I'll choose how I'd like to view the period measurement. I want to see both a digits display and a graph. And now I'm ready to collect data. The smart gate has a light emitter on this side, which you can't see because it's infrared, and it has a light detector on the other side. When something blocks the infrared beam, the sensor sends a signal to SPARKvue software. And it also lights up this indicator so you can see when the beam is blocked. To measure the period of our pendulum, I'll line up the beam with the edge of the pendulum and start it oscillating. Click Start, and we start seeing data appearing, 1 data point per cycle of oscillation. The period is 1.72 seconds, and we can also see that the period is constant. Looking at the formula for a simple pendulum, it's apparent why. The period depends only on the length of the pendulum and the strength of gravity, both of which are constant. However, we might remember there's an important assumption built into that formula, which is that the amplitude must be small. But what happens when the amplitude is large? What would we find if I release the pendulum from here? Would we expect the period to be larger, smaller, or the same? Let's find out. Now we can see the period is larger, not by much, only a few hundredths of a second, but it is larger. We can see how the smart gate makes it easy to measure the period with enough precision to detect this small but important effect. Another use for a smart gate is to measure the speed of a projectile. I have a smart gate attached to a projectile launcher. I'm using a Pasco mini launcher, but you can use any type of launcher you want. I mentioned earlier that the smart gate has an infrared beam. It actually has 2 beams spaced 15 millimeters apart. As the projectile moves through, it interrupts first one beam and then the other. And the software calculates the speed based on the time difference. For this measurement, we will use Capstone software. I've connected the smart gate through Bluetooth, and now we'll create a digits display and select the measurement speed between gates. I'll click Record to start collecting data. Nothing shows up at first because nothing has passed through the smart gate yet. As soon as I fire the projectile, the speed measurement will appear. And there it is, showing the speed was 3.14 meters per second. If we know the initial velocity and height of a projectile, we can predict its range. Let's see if we can use our speed measurement to help us place this cup somewhere on the table where the ball will go into it on the first try. For a projectile fired horizontally, this is the formula for range. To find h, I'll measure from the top of the cup to the bottom of the ball. And it is 90 millimeters. I could do the calculation by hand, but instead I've entered it into Capstone. I've set the constants h equals 0.09 meters and g equals 9.8 meters per second squared. And I've set the initial velocity to be the measurement from the SmartGate. To see the result of the calculation, we can create another digits display and select the calculation. It shows our predicted range is 0.43 meters. Let's place the cup at that distance and test the result. Of course, you can repeat this experiment with a different launch speed, height, or angle. We've seen just two of many ways you can use the wireless SmartGate. Visit the wireless SmartGate product page on pasco.com for more information about the sensor and related products like the mini launcher, photogate tape, picket fence, and super pulley. There you can also learn about other features of the wireless SmartGate, such as the laser switch and accessory port. And check out PASCO's experiment library for activities you can complete with the wireless SmartGate, like investigations into Atwood's machine, a simple pendulum, and two-dimensional motion.